Hello guys, so today in my presentation I'm going to talk about fluorine, a chemical element. So first of all, these are the things that I want to talk about today. Some is general information, the discovery, its occurrence in compounds, as well as its physical and chemical properties, and finally the production and its application. So first of all, some background information. As we all know, its symbol is an F, its atomic number is 9, and its atomic weight is around 19. And in the periodic table, it belongs to period 2, group 7A, or in some country it is group 17. And as fluorine is the most reactive element, and the reactions are mostly dangerous and explosive, so many chemists had died attempting to isolate this element. And it is not until 1886 that Henri Moissan eventually found a way to isolate fluorine, and in 1906 he was also awarded the prestigious Nobel Prize for this achievement. Now moving on to its occurrence and compounds. Fluorine is the 13th most common element in Earth's crust, and it is found only in combined mineral forms like fluorite, fluorapatite, or cryolite. And here's some of its compounds. The first one is hydrogen fluoride and hydrofluoric acid. Hydrogen fluoride is made by using calcium fluoride and sulfuric acid. And when hydrogen fluoride dissolves in water, it creates hydrofluoric acid, which is a weak acid. And hydrofluoric acid is mainly used to etch glass because it can react with silicon dioxide, which make up about 75% of glass. And the next compound is oxygen difluoride, which is made by using fluorine and sodium hydrogen. And this one is extremely toxic with powerful oxidizing properties, so it can react with most metals and non-metals. So now moving on to its physical properties. As we can see here, fluorine is pale yellow, or sometimes it is white or colorless. It is also freely soluble in liquid oxygen and ozone. It changes its phase from gas to liquid at about minus 188 degrees Celsius, and from liquid to solid at about minus 220 degrees Celsius. And also it is slightly heavier than air. Now let's have a look at its chemical properties. As I've mentioned before, fluorine is the most reactive element. It combines easily with every other element except helium, neon, and argon. And it can also react with most compounds and often violently. For example, the reaction between fluorine and hydrogen is highly explosive and dangerous, or it can also react with water to release oxygen, or metals like aluminium, and most non-metals like sulfur. So now here's the video about some of its reactions. So the first one is with iron. So as you can see, iron just catches fire right away. So the same thing goes with carbon here. Just you can see, just burn to ashes right away. So again, the reaction is really explosive. Fluorine and sodium, just the same thing, catches fire right away. So about sulfur, silicon. So we can see that this one is really explosive. And aluminium Again, it's really explosive. This one is actually fluorine and hydrogen. So, how to produce such a reactive element? Nowadays, in industry, people still use the way that Henri Moissan used 100 years ago, that is via the electrolysis of a potassium fluoride or hydrogen fluoride mixture. And there are also some other ways to isolate fluorine, like through this chain reaction. And finally, what are these applications of fluorine? So, the most familiar use is to create toothpaste or to create rocket propellant. It can also be used to create Teflon, which is a material to make tapes or non-stick frying pans, and also Freon, which is used in air conditioners or refrigerators. So that's all for me today, so I hope you guys enjoy it, and tell me what you think in the comment below, and thank you for listening.